Hi, and thank you for tuning in to Gavin Lon Digital. I'm Gavin Lon. So, in this tutorial, we are going to create a facility whereby a logged on user can use the relevant facility to choose the courses of interest to the logged on member. So to achieve this, we'll add a button to the home page that will appear to the user once the user has logged onto the system. This button will be displayed above the collapsible list that displays the courses that are currently associated with the logged on user. When the user clicks this button, a new screen is presented to the user where a full list of categories currently saved to the system will be displayed to the user. Each list item will contain a checkbox. The checked checkboxes in the list are the courses that have already been associated with the user. The user is able to check the courses of interest to the user and, if need be, uncheck those courses that are no longer of interest to the user. Once the user has inputted the relevant data, the user can click the Save button and will be navigated back to the home page where the courses of interest to the user will appear within the collapsible list. The user can then consume the content for the relevant category items that are related to the courses chosen by the user or chosen by an administrator for the user. If you'll recall, in a previous tutorial, we created a similar facility, but the facility I'm referring to is only accessible by an administrator. The facility to which I'm referring allows an administrator to associate members to courses. The administrator can choose courses to be associated with members of the system. At the database level, a course is associated with a user in the user category database table. As we know at this stage in the course, the identity table named ASP.NET Users stores account information for registered users, and this database table has a many-to-many relationship with our custom table, i.e. the category table, that stores the information for courses currently saved to the system. The user category table can be referred to as a join table and facilitates the many-to-many relationship between the ASP.NET Users table and the category table. So, at the database level, the association between a registered user and the relevant registered users' associated courses are stored in the user category database table. The relevant user ID will appear in the table next to each category ID, representing each course associated with the relevant user. I recommend that you stick around to the end of this tutorial, as later on in this tutorial, we'll implement code to register our own custom class with the .NET Core Dependency Injection system, so that we can reuse code within the relevant registered type from within multiple controller classes. For content like this and much more, please consider subscribing and please ring the bell so that you'll be notified of future releases. If you like this video, please give it a thumbs up and please feel free to share this video with anyone you feel may gain value from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will be greatly appreciated. So let's start by creating a view model within the default area of our solution. So within the default area of our solution, let's right-click the Models folder and create a new View Model class. Let's name this class Categories to User Model. Let's add a string public property to store the user ID field value. If you'll recall, the user ID field within the ASP.NET Users table is stored as a GUID. Let's add a public property of the generic type iCollection that is strongly typed with the category type. Let's name this property Categories. Let's add a public property of the generic type iCollection that is strongly typed with the category type. Let's name this property Categories Selected. So this view model will store information for the view that will display a list of checkboxes to the registered user. Each checkbox item denotes a course currently saved to the system. A list of courses saved to the system will be stored in the Categories property. A list of categories currently associated to the logged on user will be stored in the Categories Selected property. So each category stored in the category selected collection will be represented on the relevant view as a checkbox that is checked. All other categories in the checkbox list view will be represented as checkboxes that are not checked. The categories to user view model will store the user ID of the logged on user, a list of all categories currently saved to the system, and a list of categories associated with the logged on user. The code for processing the client input, which will manifest as checkboxes that have been checked or unchecked by the relevant user, will be done through the use of an action method contained within the controller class that we are about to create. Let's add a new controller class to the controllers folder within the default area. Let's name our controller class Categories to User Controller. Let's create a constructor that accepts two arguments via the .NET Core Dependency Injection system. The first argument is the EF Core Database Context object. The second argument is Identity's User Manager object. And we are setting appropriate member variables to reference each of the object arguments passed into our constructor. Before we create the code for the getIndex action method, and then the postIndex action method, let's create a few ancillary private methods that will implement code for retrieving and transforming relevant data. The private methods we are about to create will contain relevant link queries. So let's first create a private method that returns a list of categories where at least one of its related category items has associated content. So let's create an asynchronous private method that returns a list of categories. Let's name this private method getCategories that have content. So in order to ensure that only those categories saved to the system where one of the relevant categories related category items have associated content are returned from our link query, we must join data retrieved from the category entity with data retrieved from the category item entity, and then we must also appropriately join to the content entity. So the list returned from this private method will contain a list of categories where each of the relevant categories has at least one category item that contains content. If a category in the list has more than one category item that contains content, the relevant category data will be repeated, i.e., for each related category item. We want data for each category to be distinct. So we can achieve this by using link's distinct extension method like this. We must then convert the IEnumerable collection to a list. We are using async-await to asynchronously run our link query, so we must use the toList async extension method for this conversion operation. So we have written code to return a list of categories saved to the system in the getCategories that have content private method. Let's write code that retrieves a list of categories that are associated with the relevant logged on user from the database. So let's create an asynchronous private method that returns a list of categories. Let's name our private method getCategories currently saved for user. The private method accepts an argument that stores the relevant user's ID. So let's write a link query that queries the user category entity for the category IDs pertaining to the categories that are currently associated with the relevant user. The relevant user is denoted by the user ID value passed into this method as an argument. So we have written two private methods that will be called from the indexGetAction method, which will return data that can be displayed to the user as a checklist view. The relevant checklist view will contain a list of categories saved to the system, and the checked items will represent the items currently associated with the user. So we are now going to write two private methods that will be called from within the postIndexAction method. This postIndexAction method will be responsible for saving the user's input to the system. This method returns a list of user category items that need to be deleted from the user category table. To keep our code simple, we are going to write code to delete all categories associated with the relevant user from the user category table. So let's write a link query to return all categories currently associated with the relevant user. These items will be deleted from the user category table. Let's write a private method named getCategoriesToAdd for user. This method is responsible for transforming data that will be passed into the postIndexAction method, which will be an array of category IDs, into a list of user category items. We are performing this projection operation so that the data is in a form where we can later use the EFCore addRangeAsync method to add the relevant rows to the user category database table. So EFCore's removeRangeAsync method will be used to remove the relevant rows from the user category table, and EFCore's addRangeAsync method will be used to add the relevant rows to the user category table. You'll see the code that implements these two methods in a bit. So we have completed the code for the ancillary private methods that will be called from within the indexGetAction method and the indexPostAction method. Let's create the code for the getIndexAction method. This action method is responsible for returning all the relevant categories that are currently saved to the system and all the categories that are associated with the relevant logged-on user. Let's first create an object of type categoriesToUserModel. This is, of course, the viewModel class that we created before creating this controller class. Then we can use the userManager object that is being passed to our controller class via dependency injection to get the currently logged on user ID. So we can call the getCategories that have content private method to return all the relevant categories to the calling code. We can then assign the returned list to the categories public property on the categoriesToUserModel viewModel object. We can use the getCategories currently saved for user private method to return all the categories currently associated with the relevant user. Note that we are passing in the relevant user ID to the getCategories currently saved for user method. We can then assign the returned list to the category selected public property on the categoriesToUserModel viewModel object. Then let's assign the user ID value to the user ID property on the categoriesToUserModel object. We can now write the code to pass the categoriesToUserModel object to the relevant index view. We have not yet created the relevant index razor view. Once we have finished the code for our controller class, we'll create the code for the relevant index razor view. So let's create the indexPostAction method. This action method contains a parameter that is of a string array data type. The relevant string array argument will contain a list of category IDs. These category IDs denote the checked items displayed on the relevant index razor view pertaining to courses that are associated with the relevant user. So let's write code to retrieve the categories that we want deleted from the user category table. We can use our getCategoriesToDeleteForUser private method for this purpose. Let's write code to project the relevant user ID and categories passed in as an argument to this method into a list of user category items. We can use our getCategoriesToAddForUser private method for this purpose. So now the code gets a little bit interesting. We need to write the EF core code to delete the relevant rows from the user category database table, and then add the relevant rows to the user category database table. We have actually already written the code for this. If you'll recall in part 19 of this course, where we created the functionality for a facility whereby an administrator can associate courses with users, we wrote the transactional EF core code to update the user category database table. So we have already written the transactional code we need for this controller within the users to category controller class. This is the controller class that we created in part 19 of this course. In the previous part of this course, we discussed the principle of dry. Don't repeat yourself. So the question is, how can we reuse this code? We already have the code we need written within our users to category controller class, and we don't want to duplicate this code within our categories to user controller class. So let's create a class where we can house reusable database-related functionality. Let's name this class Data Functions and store this class within the data folder that resides within the default area. We are going to use the built-in dependency injection system to inject an object derived from the data functions class within any class that needs to reuse the data-related functionality that will reside within the data functions class. So let's first create an interface named iDataFunctions within the data folder. Let's add a method definition to this interface that defines a method that we'll implement within the data functions class to transactionally update the user category database table. Let's name this method update user category entity async. Let's go back to the data functions class and write code to implement the iDataFunctions interface. Then let's go to the users to category controller class and copy the code that we wish to reuse and paste it into the update user category entity async method. So let's create a constructor for our data functions class. The relevant EF core database context object will be automatically injected into this constructor via dependency injection. So we want to enable the functionality within the data functions class to be reused within any class within our application. We can make the functionality within our data functions class available to other classes by using the dependency injection system built into .NET Core. So to register our data functions type with the dependency injection system, we can update the startup.cs class. We can register the data functions class with the dependency injection system by appropriately updating the configure services method within the startup.cs class, like this. Note that we are using the add scoped method to register the data functions class. We could have used a method named add transient or a method named add singleton to register our data functions class for dependency injection. The difference between these methods is to do with when the relevant registered object is instantiated and the lifetime of the relevant object. So let me elaborate on what I mean by this. So when we use the add scoped method, the relevant type, in this case the iDataFunctions type, is instantiated once into the data functions object when a new request occurs. When add scoped is used, the data functions object created from the relevant registered type is available throughout the lifetime of that one request. If a new request occurs, a new data functions object is created, i.e. a new instance of that object is created before being appropriately injected. If we use the add transient method to register the iDataFunctions type for dependency injection, a new data functions object would be instantiated every time an object of the iDataFunctions type is injected into a relevant class's constructor. For example, if the data functions object was injected into the constructor of the categories to user controller class and subsequently the constructor of the users to category controller class during one request, a different object of type iDataFunctions would be passed to the users to category controller class when compared to the object passed into the categories to user controller class via dependency injection. A new object is created before the object is injected every time a dependency injection operation occurs for the relevant iDataFunctions object when the add transient method is used to register the iDataFunctions type for dependency injection. If we used the add singleton method to register the iDataFunctions type for dependency injection, the data functions object is created once and is not recreated with every request. So, basically, transient objects are always different. A new instance is provided to every controller and every service. Scoped objects are the same within a request, but different across different requests. Singleton objects are the same for every object and every request. If you'd like to read more about dependency injection and the difference between scoped, transient, and singleton objects, I've included an appropriate link below in the description. Now that we have written the code that registers the data functions type with the dependency injection system, let's open the users to category controller class. Let's add a parameter to the users to category controller class's constructor that is of type iDataFunctions. Let's assign an appropriate member variable, the object that will be passed as an argument to this parameter via dependency injection. So now, wherever .NET Core sees, as it were, the iDataFunctions type within the parameter list of a class's constructor within our application, it will inject the appropriate object of the iDataFunctions type that has been registered for dependency injection. So we can now replace the code that updates the user category database table with a call to the update user category entity async method, called on the data functions object. We can now open our categories to user controller class. Let's first decorate the appropriate index action method with the HTTP post attribute and the validate anti-forgery attribute. Let's now appropriately include the code that will ensure that the data functions object is also passed into the categories to user controller class via dependency injection. We can now reuse the update user category entity async method called on the data functions object to update the user category database table for the functionality where a user can choose the courses of interest to the user. Once the user category table has been appropriately updated, we want the user redirected to the home index view. We can achieve this by returning the result of the redirect to action method, like this. Excellent. So the next step is to write the code for the index view related to the categories to user controller class. So the code within the relevant index view will render the appropriate checklist view to the user so that the user can choose the courses of interest to the user. So let's first create a folder in the views folder within the default area, and we must name this new folder categories to user. Let's then create a razor view named index within the categories to user folder. Remember, through a naming convention that exists within the MVC framework, the razor views created within the categories to user folder are automatically appropriately associated with the categories to user controller class. So let's first strongly type our index razor view with our categories to user model type. This is the view model class that we created at the beginning of this tutorial. Let's write the HTML code, including relevant bootstrap classes, that will be rendered to display the appropriate checkbox list view to the user. The user can then use this checkbox list view to choose the courses of interest to the user and save the user's selected data to the system by pressing the relevant Save button. So you can see that we are looping through the relevant collection of categories here. We need to write code here to output each checkbox in the relevant list. But we need to determine which checkboxes should be checked or unchecked when the relevant checklist view is first displayed to the user. So the checked checkboxes denote the courses that are currently associated with the relevant user. So we can use links contains method to determine if a checkbox list item should be checked or unchecked. The contains method can accept an object argument used specifically for comparison purposes. By using a specific comparison class, we can instruct link, as it were, on how we want the relevant objects compared. For equality, so we want two category objects compared for equality by our link contains extension method in order to determine whether to output a checked checkbox or unchecked checkbox in the relevant checkbox list view. So within our comparers folder here, let's make a copy of a class very similar to the one we need to create. Then let's name our class compare categories and replace the user category type reference with the category type reference. We can now use our comparer class to instruct link, as it were, on how we want the relevant category objects compared for equality. The last thing we need to do is add an appropriate button to the home index view that a logged on user can click in order to access our new Categories to User Index view. Let's test the code. Excellent! For content like this and much more, please consider subscribing, and please ring the bell so that you'll be notified of future releases. If you liked this video, please give it a thumbs up, and please feel free to share this video with anyone you feel may gain value from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will be greatly appreciated. The latest code can be found on GitHub. A link to the relevant repository has been included below in the description. Thank you, and take care.